Hello everyone, and welcome to today's tutorial for Lab 6. For Lab 6 handout, today we are going to cover one of the most fundamental concepts in statistics, confidence intervals for population mean. Our goal today is twofold. The first one is to construct a confidence interval for a population mean, and second, simulate repeated confidence interval to explore long-run coverage. This handout is only for practice, and so there's no submission requirement, but I encourage you to follow along closely and run the code, and this is a key skill for the course. Okay, now let's get started. First, open this handout, and the first code chunk we see is the setup. Let's go ahead and run this. This chunk does two things. It loads the tidyverse package and the open intro package, open intro libraries. I think you are pretty familiar with these two, right? Because we have used many times for our previous handouts. And also, below, you are going to use the data called NCBurst. Okay, this is the data set we are going to use for this handout. And right below there, you can see that set seed 1, 2, 3. So you will also be familiar with it because this is we have used before. This is a very important line. When we take random samples, we want our work to be reproductive. Setting a seed ensures that every time we run this code, we all get the exact same random sample. Okay, so please run this line as well. Okay, and then finally, this is the helper functions. Actually, you can see that this is a pretty huge chunk, right? And the functions are complex, but be relaxed that you don't need to understand every single line of this, but to just know that it gives us two new functions, get, t, start. So this is the t distribution function. And the next one is the simulate CIS. So you don't need to worry about this because for your homework, you will get this chunk shown to you. You don't need to tap it. You don't need to understand every single line of it. It just tells you how to define these two functions. Okay. And we'll use these two functions later. So this one is the t distribution. I think for your lecture or discussion, you know that what is t distribution. So this is different with the normal distribution, but by using this function, you can get the form of it. And also you can use the t distribution to get the critical value, to get the p-value according to standard t distribution, okay? So now let's define our data. So in the real world, we almost never know what the true population mean, right? Because you know how many people on Earth, right? We cannot count everyone's information. So let's hear, but for this lab, we are going to pretend that the weight is our entire population in this data set. So you can run this trunk, you can run this code trunk by defining the population and sample. So you are defining the population for NC data set by using the variable of weight, and you are defining the sample by using the population data and take n of it. So now the sample size is n, right? And here n is 30, okay? And you can use this code to calculate what the sample mean and what's the sample standard deviation. So you can get the result here, okay? And then what now we have our sample. So let's build a 95 confidence interval of it. As you can see in this handout, the formulation is our sample mean x bar plus or minus a margin of error. And this margin of error is calculated as our critical value, t value. You can call it t star. And the subtractive is alpha over 2, right? And times the standard error SE. So now this function is the key point, right? Because when we want to calculate the 95% confidence interval, we have three things need to know. First one, X bar. Now, actually we know it because we already defined what is X bar mean, right? And we need to know what is critical value T star. This we can know it from the T distribution. And we already defined it, the T distribution here, okay? And the last one is the standard error. The standard error actually we can also know it by using the standard deviation function. Okay? So now you know. Okay, so now you know how to calculate the. So now you know what's the formulation of calculating the confidence interval. So let's do it one by one. To get X bar, to get T star, to get SE. So the next chunk code chunk is helping us to get it. Okay. So in this one, you can get alpha equals to 0.05. So this is corresponding to you are going to calculate the 95% confidence interval. And the degree of freedom is n minus 1. And t star here, actually, you're just using the function, helper function, to get the t star. And se is s subtract the square root of n. And now you know every parameter to calculate the confidence interval. So you can use this function to help you calculate the confidence interval, right? Okay, so now you can see that the confidence interval is actually an interval from 7.08 to 7.84, right? So now we're wondering, does this confidence interval capture the true mean? So in this section, we are trying to explain it. Okay. Okay, now you need to know what is the population mean. And you know what's the lower level and what's the upper level for the confidence interval. And if your population mean is inside this confidence interval, then the return is true. Okay. Okay, now, what happened if we increase the sample size? So remember previously we defined n is 30, right? How about n increases to 100? So actually you are just do it again, right? You just because now the degree of freedom changes, the SE changes, and all other things remain the same. You can get, according to the confidence interval formulation, you can get a new confidence interval, which is 6.62 to 7.31. And previously, by using the n size is 30, you can get this interval, right? So you can see that this is not the same by using different size. Okay. And how does this interval compare the one with n equals to 30? So actually this is an open so this is the open question because you can look at the confidence interval and to get your answer. But let's see. You can see that compared the one with n equals to 30, you can see the interval is narrower, right? So previously it from 7.08 to 7.84. Now it's just from 6.62 to 7.31. Even though the difference is small, but this confidence interval is narrower. This is a key concept in statistics. You can try to understand it. A larger sample size gives us a more information and a more precise estimate, which results in a smaller margin of error and a narrower confidence interval. So this is the concept in statistics, okay? Okay, now we can just from the one sample to the multiple samples. So previously, we just take, for example, n equals to 30 out from the population. We just take 100 samples from the population and we repeat once. But from this part, we are going to try to do multiple samples. So you can compare this part with our previous lab session by using the simulation, right? Okay. And it's just define that n result define that n equals to 30, alpha is 0.05 to calculate the 95% confidence interval. Okay. Okay. So let's. Is there something wrong with it? So if I change n from 30 to 100, this is just okay. Let's see if there's something wrong with it. Let me check the. Okay, so this is the original form. Okay, no, there's nothing wrong. Oh, okay, so I just skipped one code chunk, so that's why. So, okay, so now you can define the sample size, you can define the confidence interval, and you can also you can calculate the different sample resulting in the plotted and to see whether or not the population mean is inside the intervals. So if it is inside the intervals, you can get yes. And this is if this is not in the confidence interval, this is no. So this is also a pretty large code chunk. So my suggestion is that when you want to finish your homework, you can copy paste this this chunk and to your assignment and change some key variables. Okay. Okay. I think that's it for today because when you compare your handout and the assignment, you will notice that the only thing different is that you are going to change the variable. Here, the variable is weight, right? In the homework assignment, the variable is not weight anymore. It's annual salary, if I'm correct. Okay. So if you have any questions, please feel free to let your TA know or go to the lab session or just email to us.